hot, uh, that they're not going to be the issue. The tubing that we have that's on the inside here, right there, the white part you see right there, that goes up to about 260 degrees C before you start having issues. And 260 degrees C is pretty much right at the limit of what you're going to be able to use. Don't worry about this when it comes to higher temperature stuff. We're working on it. We've got some brand new materials we're looking at, and Carl has some fantastic some stuff that was irradiated, and he has found some stuff that's really good stuff for going higher temperature for that kind of stuff. So that can be machined all the way straight throughout. So I'm gonna let Carl talk about that when he gets back in, and we'll go and go from there. But for the materials as of right now, we want to test them out for higher temperature stuff later on. Most of the stuff, the peak is rated to 400 degrees C. You got the aluminum that, is rated much higher. You got brass pieces here, like the brass standoffs. You got a brass fitting. Your biggest issue. I'm trying to locate the greatest bottleneck as to what the biggest problem would be. The glass transition temperature for these individual brackets you see right here, for the ABS brackets we have, they're basically 104 degrees C, and I would say that's probably the upper limit. I know that for a fact that Stratasys on their machines typically keeps their build chamber environment between 50 to 75 degrees C. When it comes to the Fortis, when it comes to the Dimension, the Up, and I'm not sure about the Mojo. That I'm not sure of, but I do know about the other ones. When it comes to stuff that's a lot higher temperature, I don't know if they are object or is pursuing doing metals. I would assume that they are, in some shape, form, or fashion. But that's an entirely different kind of setup, which requires inert gas environment, and if you're going to be using laser sintering, or if you're going to be using well, the epoxy doesn't require that, but if you're going to be doing laser sintering, you definitely would want to have an inert gas environment. So, but 50 degrees to 75 degrees C for a heated build chamber is pretty darn good, and let me explain why. The beds that you see here, right here, on these engines and systems, we've been typically running right around 70 degrees C, 70 degrees C. And with ABS, it works with the hairspray. You have to have the hairspray, but it relaxes the plastic enough that it stays down and does not curl up. Especially when you use a frog finger, Davo pad, Davo disc, anchor pad, however you want to call it. It works fantastically. I've tried doing brims before. Brims, unfortunately, because they're not circular, they're not 100% circular in shape. They're more oblong, and they're not even like an ellipse. They have issues. So putting small little discs around before you start slicing things up is one thing that we're looking at and automating in our software. So little things like that. Let's see. So when it comes to the actual stuff that would be an issue, circuit boards are rated all the way up to 160 degrees C. Your biggest issues right now that I can think of are going to be your motors, if they get too hot, and if your plastic pieces get way too hot. Those are the only two things I can think of. The wires are rated to go a lot higher. The wiring here is rated to go a lot higher. And if we need to have a different type of head in order to go much higher in higher temperature, you could have that too. Oh, back to the heated bed. 70 degrees C for PLA works great. But we've also found that when you start using ABS and you go up to 100 degrees C, the PLA tends to start to flow on you. So these beds, if you run them, which they can go up to 110 degrees C, if you run them at 100 degrees, you're going to have issues with PLA. The PLA will relax on you and will start flowing, and you're going to be left with a goopy mess. Not really the most fun thing to print on. So, there you go. Let's see. Oh yeah, Powers, you say, yeah, absolutely. You can, if you want to post a link, absolutely, go right on ahead. Let's see, Eagle 1J. 80 degrees C is probably max in reality. I would say... just based upon my limited knowledge, and not knowing as much as I want to know, I would say the biggest issue is going to come down to your motor. But, and wow, he really chewed this one up when he tried making it at the very beginning. That's okay. Let's see, anything. But I would say more than likely it's the motors that are going to be your biggest issue when it comes to going really, really hot. But not to worry. We have stuff that's going to go super, super red hot. You're not going to have to worry about that. If we have to go to a Bowden type of system, or if we need to go to a way to make sure that these guys are cooled off, don't worry about it. Because I know what I can say as of right now is that the design that we've been working on looks extremely promising in order to overcome that. Okay. Yeah, solder on the board starts to crack after some use. We've noticed, even, and this is something. If you guys are ever going to get boards being made, any kind of circuit boards being made, this is a very good rule of thumb. Some board houses that are out there, when they stuff the boards, or when they put the individual components you see here on, like the ICs, the capacitors, resistors, transistors, all this stuff, when they put them on the board, some houses when they, because the pick and place machines come in there and pull the stuff on here, and when they go to actually cook them, they go up to about, I think it's like 165 is what my mind is telling me. I could be wrong, and if you guys know, please correct me. But if you go anywhere above a certain particular temperature where the solder flows really nicely, you go too much higher, and your components on your board are going to start failing. And we've noticed that with a couple of the other boards we had made actually here in the United States and also overseas, they didn't have a good process control as to what was the correct temperature. They know what it is now, and the boards that we had, well, I'm going to show you. Well, I can show you like a graveyard if you guys came by the place, but we had like 50 or 60 boards that were fully stuffed, ready for the semiconductor products we've been pushing out the door, and they fried the chips. They fried the ICs. In some cases, they actually fried some of the capacitors. So, higher temperature in this case will affect the actual boards by themselves. Soldering wise, 80 degrees C, I don't see a problem. I really see 100 degrees C being the issue when it comes to stepping motors potentially losing pulses, or potentially losing steps in this case. So this is probably going to fail before this does, from everything that I've seen and from my knowledge base, which here again is small. Take that with a grain of salt. In comparison to Carl's, it's going to be more of this versus that. Okay. Let's see. Is there anything else inside the shell of the system that can't handle the temperatures in the 70, 80 degrees C range? So the hottest I've ever seen in making chambers 80 degrees C. Surigami has active cooling ducts. Okay. Oh wow. Yes. and I know exactly what the company you're talking about. um, you know, no. The cables that we have on the inside are rated higher than 80 degrees C. That's not a problem. The aluminum, the stainless steel, obviously, and the this cold rolled steel we're using, not a problem. Uh, Circuit board material, the heated bed is not going to be a problem because obviously it's rated to go up to 110 degrees C, and we've tested it up to that point. Um, the printed parts we're doing everything you guys are getting to be getting. The printed parts that are on the inside of the systems and the engines, they're all ABS. So they're all ABS pieces. So they're rated up to 104 degrees C. So 80 degrees C is not going to cause an issue with them. Heat shield in place down below. You know, guys, I'm drawing a blank. I don't see that there's anything. I mean, once you get up to 100 degrees C, that's when you're going to start having problems. I don't see anything currently inside the systems that is going to be a problem if you were to seal up your own system. I really truly don't. I mean, heck, even the air filter that we've been using is rated higher than that. So, yeah, if you use PLA parts, depending upon the quality of the stuff, may cause an issue. I do know if you're going to start mixing in certain materials like Leiwu or Leiwood and a couple, I think there's a couple others that are like that. They require the chamber to be, in this case, not as hot because some of them require well, they just have a much lower extruder temperature. I know there's somebody else out there who wants us to do, what's it called? They want us to take a look at they want us to know if we can print a certain particular filament that was basically an epoxy that they have made into a filament. I can't remember the name of the stuff right off the top of my head, but that stuff had a really low temperature. When we're talking, it was printing at, I think, between 80 to 110 degrees C. I mean, it was really low. We don't have a problem doing that with the extruders. We just know that when you start mixing that in with ABS or PLA, when the bed by itself is at 70 degrees C, you might have issues. So there you go. Oh, are the printers shipping with material sensors? Great question. Powers, I love your questions, my man. The material sensors we're holding off on, and let me explain. Material sensor blocks, which is going to be help feed the actual material up through the fittings and then into your extruder heads. That's going with. All that's going with. The one thing that Carl continually looked at when it came to the material feed sensor blocks was, let's see, with the material sensor blocks, was that we looked at it and Carl wanted to redesign one thing on the board. And guys, you're going to have to forgive me because I can't remember what it was that he wanted to redesign on the board. I know we're having more boards made, or new boards made in this case, but it was something that he and the Sablemeister were still working out. But I do know that when they are ready, that we'll be sending those out, and it's a simple with the right screws. It's a simple screwdriver. You'll be able to lock them into place, plug them in, and they'll work just fine. The total job, I think, is like 10 minutes to do. It's not hard at all to do that. So, let's see. Ooh. Oh, clicking on this guy. I should be clicking. Wow, nice. Wow, nice. Powers USA. That looks fantastic. Oh yeah, man. All right. You got it to work. I like it. The G code came with printed unchanged. Thank you, sir. Yeah, the only issue was the printer erased the Z bed at the end of the print and jammed the part in it. Yes, because that is a problem. That's here again. This is the reason why we want to make our own slicer. So, yeah, because that kind of stuff happens. Powers, I did not forget about you and everyone else who's been waiting for the latest versions of the recipes. I'm still working on it. I'm still tinkering with Slicer and Flick 3 to get to that point. The good news is by doing this, I have a nice little backlog tally of things that I would like to put into our slicer that makes it a little bit easier to change as if you need to change those things moving forward. So, thank you, Powers. I appreciate that because he definitely needs to know that particular information. Okay. Let's see. Yeah, so I think that's, yeah. Filter, fans, a lot of extruder heads were made up this week. Yeah, it was a very productive week. And the guys got to go out to CES. So, good. Thank you, Powers. Well, any kind of feedback's good feedback, even if it's good or bad. It's good feedback. So, thank you, sir. All right. Let's see. Oh, every way is the same. Fantastic. Okay. Stall sensors would have helped with the jamming part. Yep. The stall sensors, just so everybody knows, they are installed. We even have them. I can show you where one of them is as of right now. There you go. You see on the inside, there's a little guy that's sticking out from this center part cylinder, and then you've got a Hall effect sensor right below it. So everybody's machine comes with the stall sensors intact. Now, Powers, I know you're probably going to be asking yourselves, well, why aren't they working? Because that's a software issue. That's one of the things that Carl has been working on. Well, it's been in the backlog to do. It's a software upgrade, and when Carl's ready to release it, he'll be releasing it. But the stall sensors do work. I've used the ohm meters here and there to make sure that they're talking to the board. The I/O board that we have currently as of right now, it shows up. So right now it's just a matter of getting the number of pulses put together. It's a lot of math. In between G code and what the stall sensors or what the actual clicks are supposed to be when it comes to the revolutions that are there. So. But yes, your machine has the stall sensors. Everybody's machines have got the stall sensors already put inside of them. So you don't have to worry about that. Plus, Tim, if you're watching from Australia, yours also has them in there as well. So the very first ones that went out the door to Greg and to Tim, they're in there. So there you go. Great question. Will those two systems be the only ones shipped this week? Yeoman, I certainly hope not. When Davo comes back, I think it's supposed to be either tomorrow or Tuesday, depending upon where he is driving-wise. I need to give him a call, find out where he is. He and Yevgeny. The only thing we're going to be doing this week, because we have, so many, come on, guys. We're ready for this. I'm ready for them when they come back. We're just going to be putting together system after system after system, engine after engine after engine, and get these guys staged and ready to go out the door. Test them, burn them in, and get them out the door immediately. So the 4 that we have underneath in the other room have been burned in, but here again, we just didn't have the heads. That's been the bottleneck. I've been trying my best to alleviate that particular situation. So there you go. And Ego and J, yes, I hope mine goes to boxing too. Yes. So the one that's coming back. I think that's just about it from off the top of my head. I'm sorry, guys, if I wasn't able to provide any more help via email this week. I had to knuckle down and bear down on this stuff as much as possible. Otherwise, it wasn't going to get done. We only had a small skeleton crew who was here. As I said before, I'm just thankful that Sable came in and did what he did for a couple of days. He had a lot of personal issues that he had to work through, car issues. And Ellen, who came in, she helped out a lot with the admin stuff, and along with the extruders that you see here. So we knocked out as many as we could in a assembly line fashion. So making sure everything is up to the same quality. So there you go. Great feedback. Yes, Powers, thank you. Shipping manifest, yeah, that is double checked and signed. So, Ego and J, yes, you can. Double checked and signed. Yeah. Thank you, DeCosta. Have a good night. And I know you, on the care package, I made for certain that you have that you had at least the packing slip put inside there. We have one here as well. But you're right. I need a place for a signature, so I'm going to put that on right after this broadcast and get that there, so the process is complete. So thank you for that. Yes. Ego and J, yes, that was your system sitting there right next to Mr. Michael Schmidt as he came by. So, and yeah. And so everybody knows what the care package is, just so that you're not having to say what was going on. When we put these guys together, the packing that we we forgot to include a couple of pieces. It happens. One was our wire brush. Another one was the PTFE tube. Was the not the PTFE tubing. It was the tubing for the fitting. And can't remember what the third thing was, but there were a total of 3 things that were left out, which we sent promptly, and I believe Powers USA. Thank you for sending me via Google Chat. That I believe you got that too. So, yeah, chiefly the tube. Yeah. So, good stuff. Anywho, schedule wise, you guys need to know this. Carl will be here for the next couple of days, so, but only for 2 days, and then he'll be flying back out again to Europe, and hopefully delivering this guy to one lucky Kickstarter out there, and to Europe, who is going to be getting in the engine, and he'll be coming back. I think it's a 3 or 4 day trip. And then he's got a couple more days here before he flies out again. And in that trip, he's going to be gone for a week, possibly a week and a half, possibly 2 weeks. So in the meantime, myself, Davo, Ellen and Sable are going to be here working away on your machines. So if you have any questions, please don't hesitate to get in touch with us via Skype. We have Skype on practically all the time now, and yeah, and we can go that route. Allen wrench, yes. Okay, good. So you had that one, so it didn't slow you down. So you did, okay, you did find it. Good. Yeah. I think that's just about it. Yeah. So I know I kind of came at you guys at somewhat like a fire hose. I apologize for that. But here again, if you're watching the broadcast and you have not taken the training classes, we strongly urge you to do so. To do so will help expedite your us shipping yours to you when we have it ready. So otherwise, we will not ship unless you have those. You've taken the training classes. For everyone else who may not be watching these broadcasts, but I'll be sending out an update as well via Kickstarter. Still working on the videos, and the videos will have a little bit of a refresher course for everyone, open and available. And but I think that's just about it. Yeah, I think that's just about it for tonight, guys. So, before I go, I just want to show everyone. Let me see if this works. What Mr. Powers USA had done. And whoop, nope, not that one. Let's see. Try this. That is his print. You see right here. He did a wonderful job. So, yeah. So good stuff, Powers USA. And yeah, we'll be getting you guys up and printing a lot better, a lot sooner. So anyway, oh wow. Now Powers, do remember that a lot of that stuff, if you're going to have any kind of issues with the torture test, most of it has to do with the slicer. Most of it has to do with the G-code. Most of it has to do with software. In fact, I would say all of it has to do with the software. So, just so everybody knows, because there are start stops, there are accelerations, deaccelerations, there is support material, non-support material. There's a lot of things that go into that particular torture test that they did this year and last year. So, just so everybody's aware. Very good. Thank you very much, guys. If anything else, here again, reach out to us via email, contact us, all the good stuff. 90% of your 90% of my issue is slicing too. So, yeah, good stuff. All right, guys. Yeah, quick cast, and we'll see you on the next broadcast. It may be Wednesday, it may be Sunday. When I know, I'll update everybody via Twitter, Facebook, and obviously through Kickstarter. So, all right, guys. Have a good night, and we'll see you later. All right. Good night, guys. Oh.